My name is Faith Ekstrand, and we've got Karol Herbst over here, and we're going to be giving a quick update about Nouveau and NVK. Hopefully this is a little bit more interesting, has a little more content than maybe your average State of the Nouveau talk that we've heard over the years. We've been doing a lot of cool stuff, and we're really excited to sort of share what's been going on. Quick overall overview, we've got some kernel stuff that's been happening, new AU API, GSP firmware, hardware support, we've got a bunch of user space stuff that's been happening, and we're going to try and go through all of it today. All right, so we'll start off with the kernel. One of the things that we had to do in order to get NVK up and going is we need a completely new user space API. Vulkan presents a different set of challenges than OpenGL, and the old API was not really up for the challenge. One of the things we needed arbitrary sized command buffers, whereas the API had a hard limit of, I think, 512 push buffs or something like that. We also needed an arbitrary number of BOs in a single submission, and the old one had a hard limit of like a couple hundred. I don't know why we even tried to claim that we had OpenGL with bindless, because we really didn't. We needed to be able to handle memory aliasing of tiled images. That was not possible thanks to Nvidia's lovely usage of putting the tile mode in the page table entries, which meant the tile mode had to go on the buffer, which does not work for Vulkan. We wanted sparse resources. We wanted explicit synchronization, which had not been hooked into the new API. Lots of stuff was missing. So basically, we tossed the whole API and created a new one. The new API is based off of, one of the cores of it is this VM bind diactyl. VM bind allows you to take a range of a buffer and apply it to a memory address. And we use that for everything. Gone is the create a buffer and get an address back. We just give it the addresses. Sparse binding is fully supported, so we have page aliasing with multiple pages, with the same page going to multiple VAs. We have sparse null pages for soft faults in texturing. We can bind things either immediately, or we have a pipeline system where we provide a set of sync objects in and out. It gives us everything, so it gives us everything we need for sparse. And the big thing that it gives us, which made Vulkan even possible, is the tile mode and the PTE kind are set at VM bind time and not at BO creation time, which means now we can have multiple depth buffers with different formats overlapping each other, like the Vulkan spec requires us to be able to support. So yeah, it gives us what we need for Vulkan. It gives us, yeah. New exec diactyl, it's much, much simpler than the old one. Gone is the BO list. It just assumes that everything is VM bound, and that's it. When you have, we also added a flag. I didn't really talk about that in the slide, but there's a flag on BO create that says whether the BO is exportable or not. And for non-exportable BOs, we now have a single DMA reservation object for all of them. And so we don't have to walk lists of buffers and lock them. Instead, we just take one lock and move on, which makes submit way faster. The actyl itself just takes a list of addresses and lengths. It doesn't actually need to care about what buffers are there because they're already bound, and we just fire them off. And it's now 100% explicit synchronization. So no more implicit sync on BOs, no more hacks inside Vulkan where we have sync objects that are backed by BOs. That was awesome. And everything is now DRM sync object. So yeah, all the implicit synchronization stuff is gone. If we want to do implicit synchronization for something like Windows System integration, we have the DMA buff import export sync file actyls that I added 2 years ago, 1 year ago, I don't remember, which mean that we get real, from Vulkan's perspective, we get real explicit synchronization, and from the perspective of the Wayland compositor that's running in Glass, we get implicit sync, and everybody is happy. And we also have timeline sync objects from the beginning. So we get timeline semaphores and import, export, all the good things. So there's the new kernel API, and I will hand it off to Karol, and he's going to talk about GSP and a few other things.
Test. Oh, okay, already working. So NVIDIA, I think it's already a year or more ago, released the so-called GSP firmware inside with their open source driver, and that's something we will use in Nouveau as well. It gives us reclocking, all the good things we are missed out in the past. And there are already some patches merged for this. We had needed a quite bit of display-related rework, which is already merged. And we have a couple of tests on the mailing list, which are getting worked through and merged as soon as possible. The annoying thing about this firmware is it's 25 megabyte big per file. And we need them, currently we need 2 of them. And because we have to ship old version of this firmware file and new version because of kernel rules and everything, and we will support more generation going forward, this will explode. This will be a huge problem for distributions if they don't change the way they are handling firmware files. Currently, for example, Fedora has 3 kernels installed with 3 init RAMFS files. So we already have 150 megabytes just wasted on the firmware files. If your boot partition is 1 gigabyte big, you can run out of space soon. So to tackle this, Dave came up with an idea. It's somewhere on the mailing list. It's quite old, but it's basically an idea to version group of firmware files so that user space can say, okay, I have this 100 files, but I actually only need 10 of them because the kernel already supports the newest ones. So that's one way to get rid of all the old firmware files we don't need anymore. And hopefully this will be enough. But maybe the firmware file is getting bigger. Maybe we have to, or distributions have to figure out a way to not include firmware files into init RAMFS, because I think this is a problem which has to be solved one way or the other in the future anyway. But what's actually good about the firmware files is that it's the first time we actually use the same firmware files NVIDIA is using. Before, with all the going with Maxwell 2, NVIDIA gave us special firmware files which were different than the ones they were using, so we couldn't just use theirs to get new hardware support. But in the future, by just using the same ones, we can enable hardware much quicker and don't have to wait for NVIDIA to give us the firmware files we need. Yes, and this kind of gets us to Ada support and kind of also Ampere. Ada will require GSP because NVIDIA won't give us the old style firmware files we used in the past. So yeah, Ada support has to wait a little more until all those patches are merged and the distribution figured out their firmware stuff. OpenGL support is merged for MP in 23 and for Ada in 23.2. I've tested it locally with GSP. You can't test it, but it's in Mesa, so you just have to wait. And it also should just work in NVK once that's there. NVIDIA also released Hopper as a GPU. Sadly, nobody has been able to actually test if the Nouveau code is working with it because the hardware is expensive and nobody really has it. If somebody of you has it, please give it a try. We know that the compute support is a little bit different, and the GPU support is also kind of weird, but I think from a hardware perspective, it works the same. It's just very slow. So there also have been a couple of OpenGL improvements. I fixed multi-threaded OpenGL, which a lot of users are hitting now, and I think they are actually using fixed Mesa version by now. So if your Slack application doesn't crash anymore, it's because of this. And other Electron applications. Chromium actually added a workaround for Nouveau, so they didn't hit it, but all the Electron applications didn't apply this workaround. So if those crashed for you in the past, it should be fixed now. And I've also managed, and others as well, managed to fix NV30, which is like, I think, 20 years old hardware or something. But it has been broken since forever. And there was some really weird bug, and if you started GNOME with it, it's just random garbage rendered on the screen. But it should work now. So in case you have an old GPU, it should work. So yeah, let's talk about NVK.
All right. So we've been working pretty hard on NVK over the last year. And everything I'm going to talk about has just happened since XDC last year. So first thing is that we've implemented a few features. I apologize for the font size, but I had to get it all into one slide. There are 62 extensions and feature names on there that are interesting. I will point out a few of them that are of particular interest to people. First is geometry and tessellation shaders. We did not have those hooked up. The compiler work was basically already done because at the time we were using the old Nouveau compiler, but we hadn't actually done the work in the pipeline to get stuff hooked up into the compile process. Those are up and they work now. I had a GSOC intern over the summer who did YCBCR, which was not especially interesting to a lot of people, but it is one of the big Vulkan 1.1 features, and it had a pretty big impact on the driver itself because it involves multi-plane images, and for anybody who's worked on a Vulkan driver, those kind of end up all over everywhere, and so that was a big refactor that happened. We have a bunch of the extensions that are needed for DXVK. We've got like the depth clip control, depth clip enable. We've got all of the maintenance extensions. We've got all of the extended dynamic state extensions. So all those good toys. Joshi was bugging me yesterday about depth bias control, and I am working on it, but I don't quite know how the hardware works yet, so we're still figuring that out. But we've got a lot of what's needed. I don't know that we have everything for DXK quite yet, but we do have some apps that are up and running. We have somebody on our channel who's been playing with DXVK successfully for close to a year now. But I haven't been out specifically testing games. I've been focusing on trying to get CTS tests passing. But yeah, we've got most of what's needed. We should also have most of what's needed for GL 4.6 on Zinc, as well as lots of various app things. Again, not incredibly well tested, but theoretically we have most of the features. We also merged into Mesa Main. So that happened, what does this say, 2 months ago? We landed in Mesa Main. It's all hidden behind the Nouveau experimental enable. And it's going to be called experimental for probably a little while yet, because even though we're in pretty good shape these days, we're still working on filling in a lot of stuff, and it hasn't gotten broad testing, but lots of stuff is working. Currently, we are supporting Turing and later GPUs. We're hoping to backport that back to Maxwell and maybe even Kepler. Currently, everything Kepler and later will enumerate if you enable the I want a broken Vulkan driver flag. And if you enable the I want a broken Vulkan driver flag, you get what you asked for. So please be aware of that. But yeah, everything back to Kepler should enumerate. Maxwell works pretty well, at least Maxwell B. I have not really done anything on Kepler, so it's probably a dumpster fire, but in theory it will enumerate. We require a Linux 6.6 kernel. This is because that's where the new UAPI is going to land. So the new UAPI is basically required for properly implementing Vulkan, so we are not supporting the old one. We had code for a while when we were originally bringing up the driver, but that code has since been deleted. It is gone, it is dead, it is never coming back. You need a 6.6 kernel, or you can grab DRM-MESC fixes. That also has everything in it. And yeah, we're not going to do the old one. Currently, as I said, it fails 4 CTS tests. That's not true. It fails 0 CTS tests. We'll get back to that. The last year, if you've been watching the main NVK repository and wondering why things have been a little bit quiet, it's because I have not been working on NVK primarily. I've been writing a new compiler. The user space stack is getting a complete top-to-bottom refresh. And part of that means new compiler. Among other things, the new compiler can actually reliably allocate registers, which is good. That's always been a bit of a problem. So yeah, it is a completely brand new code base. It's being written in Rust. the next talk is going to be about my experience writing a compiler in Rust and whether or not I think it's actually a good idea and if I'm having fun or pulling my hair out. And I'm currently targeting Turing with it. I haven't actually enabled the encodings for Maxwell and earlier. Mary has a branch for Maxwell that she's been working on, but it's still kind of in process. I don't think you can really pass much, but she's got some of the basic stuff in coding. But yeah, more compiler stuff in the next talk. And yeah, we're passing a lot of CTS tests. We're currently at 400,000 tests passing with 0 fails. We'll just highlight that number. That is as of the Valve dinner on Monday night. I finally got the results in. So yeah, we are in very, very good shape. I will be submitting performance immediately after the talk. So that's, yes, we have, and that is with Vulkan 1.0 specifically. We are not to 1.1 yet because 1.1 requires subgroup support, which I have not enabled in the new compiler. Also, these numbers are with the new compiler, not the old one. The old one does not able to allocate registers well enough to pass the CTS. The new one can. So things are looking pretty good. Does NVK run your favorite app yet? I don't know. Go ahead and try it. The reality is that I've been focused on trying to get the driver written and not trying to test all the apps. Different people have different ways of approaching this sort of thing. I'm very much a CTS-first developer. Some people are very much app-first. But I do know that some apps do run. And I was demoing at the Collaborate get-together earlier this year with a couple of racing games and Hollow Knight I had running as well. So there's some games that do work, but I don't know if any particular one does. That same thing applies to, games on Zinc and basically anything else. Like, go ahead and give it a try, but I don't know. What do we advertise currently? Vulkan 1.0. That will get eventually bumped up. I'm hoping that we're bumping up to 1.3 before too long, but like I said, there's compiler stuff that needs to be done. We need to do subgroup operations. We need to verify that the memory model works. There's a bunch of other stuff, but we are, like you saw on the feature slide a little while ago, we have most of the features to get there. It's just a matter of getting the last few gating bits to be able to click off the versions. When are we going to get Vulkan? Okay, that's my question. When are we getting Vulkan 1.3? So soon, very soon. So yeah, that's NVK. And then I will let Karol, wow, brain's not working. I'll let Karol do a couple of community updates.
Yep. So I don't know if everybody here saw this email from Ben, but Ben effectively resigned as a Nouveau maintainer and developer. Ben has been doing a lot of great work on Nouveau, enabled all the, done a lot of hardware enablement, recently worked on GSP support. So most of the code you will see merged for GSP is all Ben's work. Well, plus some fixes on top of that done by Lute and Danilo probably, but I think mostly Lute is working on that. But yeah, it's sad to see Ben go, and he will be missed by everybody, I guess. So, yes, so Ben stepped down. Lute and Danilo will cover the kernel bits going forward. Danilo landed or worked on the new UAPI bits Faith was talking earlier about. Lute will mostly focus on display-related things. So in case you're running into issues in one of those areas, you can reach out to them. Faith will be maintaining the NVK driver, obviously. And through all the work on NVK, we got a lot of new contributors. Some of them contribute code, others contribute in terms of testing and making sure their favorite games are running. So this is a big help, and it's good to see this change, because in the past the Nouveau community kind of shrank down and more people were going than actually, coming to the community. So that's really good to see. I will be mostly focusing on maintaining the OpenGL driver. And if anybody of you is interested in helping out in any way, please do so. Testing is much appreciated. A lot of the stuff I've been doing in the past is just tracking down regressions. So if you have some time and want to test new kernel releases early with your NVIDIA hardware, please do so, and file bugs, and then we will be taking care of those. So I've also asked for some questions beforehand on Mastodon, and I think one big question which will also come up in the future a lot is, what do we do about CUDA? Because that's kind of, with NVIDIA, and people are just interested in seeing this happening. And I think it's really complicated to answer. Nobody of us currently has actually time to work on this. And from a MISA and also compute ecosystem point of view, it's kind of a weird target because it's a closed API. We can't really do anything. We just have to eat what NVIDIA is throwing at us. So the motivation to actually work on this is pretty low. If anybody has spare time and would like to do a MISA implementation of CUDA, they can work on that, and if they submit an merge request at some point, it might get reviewed and merged. But yeah, I think it's just it's unknown what will happen in this term, in this regard. So users are also asking if their next GPU should be NVIDIA, which I think that's kind of an upgrade answer to what we had 1 or 2 years ago, because then it was a straight no. But now if you want to help out, you can get a new NVIDIA GPU. If you expect things to just work out of the box and get great performance and everything, then maybe try in 1 or 2 years. Performance won't be great until GSP is merged. NVK is also not really optimizing for performance right now, so things are pretty slow. But yeah, we will get there eventually. So, any other questions?
Hello. Is the plan to keep the existing Gallium GL driver around, or is the plan to start using Zinc?
I think the plan is that we don't have an answer to that right now.
Okay.
I think I'm pretty vocal about torching the OpenGL driver. I think that's not a big secret if you're following what happens on the IRC. And I think we have to keep it because of old hardware. And the biggest problem is that the OpenGL driver is split in 3 parts. We have the NV30, NV40, and NVC0 driver. And originally, I kind of hoped we could torch the NVC0 one, which is Fermi and newer. The problem is that Fermi Wilkinson powered will probably not happen until somebody with a lot of time and dedication is working on that. That's unfortunate because it kind of means we have to keep all the drivers. But we might be able to remove some of the new hardware support once Zinc actually provides benefit to users. We could also start to use the new compiler with the OpenGL driver, which would also fix a lot of bugs. So I think that's kind of the overall situation.
Yeah, I think overall, when we talk about like Kepler and newer, I think we are going to burn the old driver to the ground. The question is whether it's going to be replaced with Zinc, or if we're going to decide that it's actually worth it to write a Gallium driver at some point. It shouldn't be hard to write a new Gallium driver with the components that I've built for NVK, but there's a lot wrong with the current one. And it probably needs to be started from blank files if that's what we want to use. And the question is whether it's worth doing that over NVK or over Zinc. And I don't know that we have a solid answer to that. Like, if Zinc is working well for users, we probably won't bother, but.
So I noticed on your impressive feature page slide, you have several features related to sparse. And I'm just curious how you managed to write an entire Vulkan driver for reverse engineered hardware, plus a new compiler and an image layout library, supporting sparse, faster than Intel could support sparse.
That is a question for Intel, not for me.
I don't think the new NVK driver is really that much reverse engineered because we actually and Nvidia actually released header files for all their acceleration blocks on the hardware. So we have at least all the names, and there's also sparse in some of the names, I think. So
Well, I mean, the sparse doesn't really show up in the headers. It's more about like image binding and memory binding. But it is true that like NVK isn't really properly a reverse engineered driver because we did have all of the headers with all the things. I had Nouveau GL to look at as an example of how to set up the hardware and get it initialized. So like my start was basically look at Nouveau dumps or look at what Nouveau is doing on the GL side and just kind of do that to get started. So we weren't really starting from zero. So that's part of why we've been able to go as fast as we have. But some of it is just because, frankly, the Red Hat kernel people have been amazing. I told Dave I need a new UAPI. This is what it needs to look like. And about 6 months later, there was a merge request sitting there with NVK changes. And about 3 or 4 months after that, he's like, yeah, you should test this out and let's try and get it merged. That's much, much faster than I had experienced with the Intel kernel team. But yeah, so they've been fantastic to work with. I didn't have a call-out slide, but Danilo has been amazing. Ben has been working hard. I haven't interacted with Ben much, but he's been working hard on he was working hard on the GSP stuff. Dave has kind of been coordinating things. We've had a bunch of contributors. We had Mary has helped out with some of the stuff to get Maxwell enabled, and she's helping me out with NAC right now. We've got Thomas and George, and I'm trying to remember who else have just showed up in the community with merge requests. That has been amazing. I had Mohammed over the summer. He did YCBCR. We had, I'm blanking on names. I am bad at this. I should have put it all in a slide. But we've had a bunch of people who've shown up and done work and helped out, and it has been fantastic. It's great, really great to see community coming up, and everybody's been pretty good. People bug me about VKCube a little bit too much, but it is working now. Other questions?
Not a question, but more of a comment. If you are interested in working on Nouveau, we are hiring Red Hat as well as a replacement for Ben, and partially is going to work on Nouveau as well. So feel free to reach out to me if you are interested.
I don't see any more hands, so I think we'll go into the break. And then